Today I will show you how to solve simultaneous first order ODE by Runge-Kutta fourth order method by using MATLAB software. Here I am using Octave software, but code are same for Octave as well as MATLAB. Now here the two simultaneous ODE is there. So one is dCA by dt CB minus 4CA by 50 and dCB by dt 4CA minus 4CB by 50, and condition is given at t is equal to 0, CA is equal to 0.5, CB is equal to 0. Now at t is equal to suppose 2, what will be CA and what will be CB? So that I am going to solve by Runge-Kutta fourth order method by using MATLAB software. The hand calculation already given in part 1. Now this is part 2, how to solve by using MATLAB software. Now these are the formula, or I can say how to calculate different slope for Runge-Kutta fourth order method. So K11, K21, K31, K41, these are the derivation or formula. So that I have already given in the slide. So now here dCA by dt is equal to CB minus 4CA by 50. So that is function 1 of t CA CB, and dCA by dt that is equal to 4CA minus 4CB by 50, and F2 is equal to t CA CB. And then after that we have to calculate K11, K21, K31, K41, K12, K22, K32, K42. After calculating all this, so for this first equation, so we have to calculate K11, K21, K31, K41. For second equation, we have to calculate K12, K22, K32, K42. But function 1 that is depend on T1, CA1 and CB1, and function 2 also depend on TI, CAI, CBI. Okay, now how do you calculate that? And finally, after getting K11 that slope, so we can calculate that CAI is equal to CAI plus 1 by 6 K11 plus 2K21 plus 2K31 plus K41 into H. And similarly for the second equation, so we can get that CBI plus 1 is equal to CBI plus 1 by 6 K12 plus K22 K232 plus K42 into H. And finally that is the incremental of time step. Now one by one. So for this, how do you write in MATLAB? So here, okay, before that, so first in MATLAB, so CLC I put here. So CLC is the clear of the skin. Okay, that I can write clear of screen. Then if any variable is assigned before, so that if you want to clear that variable value, so here you can use clear all variable. Well, okay. Now here CACB, okay, so that is not required. I have already discussed in the part 1. You can go through it. Now here TI is that initial time. TI is initial time, and TF is the final time. So final time. Okay, now here assume you can change that. Assume H, that is time step, is equal to 0.1. We can use 0.001, whatever that is. Actually we are doing in we are solving by using MATLAB software. We can vary that. Okay, so this is time step. So here I am taking time step 0.1. So based on that we can calculate number of number of iteration we can calculate. So that is n. So int 16. So getting that integer value tf minus ti by h. So number of time step. Then here, so t is equal to 0 again, and CA is equal to 25 by 50, so that is 0.5, and CB is equal to 0 by 50, so that is 0. Now, so storing the CA, CB and T, okay, so for that we are creating zeros, that zeros row. Okay, number of rows. So CA zeros n1 and CV zeros n1 and TC zeros n1. So storing the value. So store the value of the variable. Okay, now so F1, so here dCA by dt, so F1 TCA minus, so that is dCA by dt CA minus 4CA by 50, that is function 1 depend on TCA CV. So now here I am creating F1 TCA and CV. So that is the first equation. So that way we can create the function. And this is second equation, that is F2 at the rate TCA CV and 4 minus CA minus 4 into CV by 50, that is second equation. Okay, second equation. Now here initial condition T is equal to Ti, and okay, T is equal to Ti, that is the initial condition. Now for I is equal to 1 to n, means here we already calculate number of time step, so that number of iteration actually happen here. That we can calculate, means MATLAB will calculate the number of iteration. So 1 is to n. Now here the storing the variable, this one. So CA I plus 1 CA, CB I 1 CB, this underscore C I 1 T. Okay, so this is the storing the variable. Now that K11 we are calculating K11, so that is F1 TCA CV. Okay, so this one, and then similarly K12, that F2 TI CAI CV. Okay, so that we are calculating here, just calling the function. Similarly K21 F1 T plus 0.5 into H, so that one K21 Ti plus 1 by H, so T plus 0.5 into H, CA plus 0.5 K11 into H, and CBI CV 0.5 into K12 into H. Okay, so these so K21, so whatever equation we derive that, or we write in the slide, so that we are doing here in MATLAB. Okay, similarly K22, so okay, F2 into Ti plus 0.5 into H, CA1 half K11 into H, CBI plus, so that actually doing here. Now K31, similarly K31 F1 T plus 0.5 H plus CA 0.5 K21 into H, CV plus 0.5 K22 into H. So that we are doing here in MATLAB. Okay, now from this K32, so whatever it is there, so we are writing here. Similarly K41, okay, and K42. Now next we have to calculate that CA. CA is equal to CA plus H by 6 into K11 plus 2 K21 plus K31 plus K41, right? And that H is actually I'm taking in font, right? H by 6. CV is equal to CV plus H by 6 K12 plus 2 into K22 plus K32 plus K42. Okay, so now end. So that loop will run and it will calculate up to that desired iteration. Okay, now that is the end, and finally I am creating one matrix. We can easily get what is the T, CA and CV. Okay, so what is the value actually getting from that RK4 method, so that I am putting here. So display the result. Okay, display the result. Then plot T versus CA and T versus CV. So if we plot, we will get that. Now hold on. Okay, so another inbuilt, I am using inbuilt function, and I am going to plot together, means whatever data we are getting from RK4 method, that we can plot whatever data we are getting in inbuilt function, both we can plot in the same graph. So that's why I am putting hold on. Now inbuilt function. So inbuilt function, we have to create the function. So function that is at the rate of TC. C is a matrix Okay, so that matrix is C is nothing but, okay, C is nothing but again C is nothing but one matrix like CA and CV. So both variable we can assign as a C, and then I write first function here in terms of CA1 and C2, and second equation, not the second equation we are writing like CA1 and CA2 50, and this is the calling of that ODE45 inbuilt function T and C. Okay, so that is the desired output ODE45, and then calling the function, this function, and then this is the time span 0 to 2, and initial condition CA means C1 is 0.5 and 0. If we do that, we can easily solve, means that will call the ODE45 and it will solve. So two inbuilt function means if we know how to use inbuilt function, only 2-line code. Okay, using 2-line code we can easily get the result. Now then plotting whatever result we are getting from that inbuilt function, that we can plot in the same plot that previously we already plot that, and we put hold on and plot T C that C colon then 1 and the T C2, right? So again we can plot T versus C1 and T versus C2, and then we are putting title and X level, time T, and solution C, and legend I am putting, so here 4 legend is there, so CA RK4, CV RK4, and CA ODE45, CV ODE45. So these are the whole code for the Runge-Kutta 4th order method for simultaneous ODE. Means 2 ODE are solving parallelly, and this is the code. Okay, so this is a very simple code. Okay, and if you go one by one line, so it can be easily understood. Now we can run that code. Okay, now if we run the code, now here I'm just putting the command window and run, save and run. Okay, if we run the code, okay, so we can easily get, so Ti is equal to 0, Tf is equal to 0, H is equal to 0.1, N is 20, T is equal to 0, Ca is equal to 0.5, Cv is equal to 0, function 1, function 2. Now these are the results. So this is the T. Okay, so 1.9 up to, so here we have to put N plus 1. Okay, so if we do that, and again if we run, so you can see that this is 2.0, so 0.4274 and 0.068 means, you know, at T is equal to 2.0, that Ca is equal to 0.4274 and Cv is equal to 0.0682. Now if we plot, so plot is like that, so we are getting that plot. So it is very well matching with ODE45 and RK4 method, right? So this curve is that Ca, no, this is Ca, okay, and this is Cb. So this is perfectly matching. Okay, now even if we check, so this is the RK4 method result, and if we want to see the result for that ODE45, so we can run that. Okay, see here, so this is that ODE45, so that is their step size is different, and finally if we see that their result is same. When ODE45 we are getting that at T is equal to 2.4274 and 0.0682, and for RK4 method also 0.4274 and 0.0682. Now this is matching well, and now we learn how to solve simultaneous ODE by using MATLAB software. That's it. Thank you. So this is the code.